We are basically a physics-based simulation company. In fact, ProSim, we started the simulation technologies and adaptation and introduction in India in late 90s. When even the 3D CAD models were not available, we started 3D simulation of a very complex process like metal forging, metal casting, etc. So that's how we started. And now we are completely focused on energy sector. We work in all sectors of energy, including nuclear power, thermal and oil and gas, all sectors of power, including hydrogen and renewables, etc. We have been working. Many of the people here are my customers, including the Nuclear Power Corporation guys, Indian Oil, HPCL, BPCL. All these are our customers directly or indirectly. So I will not dwell anything much deeper. I will just show one slide what we mean by multi-physics based simulations and how we provide solutions. As we discussed in the morning, there is a physical asset, and in this physical asset there are different physical processes going on. They could be chemical process, flow induced vibration, thermochemical process. There are multiple physics based things going on, and they will affect finally the performance of this. Sridevi made a very nice point about how the enterprises at enterprise level there is a problem felt, and how I am going to show in this one slide, especially the bottom pictures, how we are helping this enterprise to solve these enterprise level problems using this simulations approach. One is simulation as a tool, and then the capability to analyze these results and provide engineering solutions. This is the key. The top two pictures are straightforward. There is a pressure vessel, there is something going on, there is a wall, there is some flow going on. That I will not dwell upon that. The bottom one is very important, and this is a very tricky one. The enterprise level problem was, this is a slurry, there is a pump which is pumping the slurry, and then this is distributing. And the problem is, this is supposed to be working. People were talking of frequency of maintenance, frequency of inspection. This was supposed to be inspected at an interval of 1 year, but then this distributor had 4 outlets. 2 of the outlets were prematurely failing. Failing matlab they were wearing out, and it was the flow had become not uniform, non-uniform. So this was the challenge, and this was located in somewhere in the southern part of Chile, in a remote area. This equipment was supplied by a European company. This was the physical challenge. So the enterprise challenge is, because of the failure of some liners, then there is a challenge that the frequency of inspection and maintenance had to be increased to twice a year or 3 times a year. This was the challenge. And then we got all the, because it's in Chile and these people do not speak English, we had a lot of these kind of non-technical challenges. Finally, we figured out the challenge is to do with the flow of the slurry. So we modeled the entire pump, then entire distributor. Then we realized where is the problem. And then we provided a solution which was simple enough. But in that time, that's how a combination of IAC, company like ProSim and companies like Flutura, that will be a wonderful solution. Here the distributors had liners which were made of some very unique type of rubber, and then that rubber characterization this customer did not have. He was a user, but he didn't have. And the producer of the rubber liners, which was from Australia, he didn't have the properties that were needed. So we approached IAC and then some companies here to characterize the wear and friction behavior of these liners, and that's how we did the whole problem. We were ready to provide the entire solution, but based on the simulations, we provided a simplified solution. We optimized the design, and then we gave a solution. The customer said, this is good enough, this is working. We will not go for any further detailed investigation. So in this simple case, we had an issue of flow to be solved. Then we had an issue of design to be solved. The flow had to be made uniform, and the velocity turbulence in these flow corners, that has to be optimized. All these kind of things were done. And then finally this design, whatever was done, this has to be approved by the authorities, and this has to stick to the standards, whatever the codes and standards applicable in that country. So all these were done by ProSim. So this is the way we provide solutions, and this combination I feel is very great. And in fact, with the Professor Jagdish, who is unable to be here with us today, we provided similar cases for many of the other issues. We have discussed several projects, and in some of the projects we have worked together. I think, Suresh, I don't know if you are familiar, there was an issue of modeling of the mud and sand which had to house these armors and ammunition. So that was one of the project where we started this kind of discussions. So this kind of consortium can provide real complex solutions for complex engineering problems. That's what I want to say. And at ProSim we have experience in working with such partnerships, whether with institutes like IISc or other institutions or other companies also. So I think this will be a good start. I thank Professor Jagdish for initiating this, making this initiative. Unfortunately, he is having some medical issue, personal issue, but thanks to his commitment and professionalism, today morning he came in spite of his difficulties. He had a surgery, and just yesterday afternoon, the stitches were removed after the surgery. But still he came today morning and he gave a wonderful and inspiring speech. I love the company of Professor Jagdish, and of course our charming hero here, Derek. He's a wonderful person too. Jagdish is the person who has introduced me to Derek and Flutura, and we have been discussing a lot of things together. I hope all of us will have a wonderful time together with these associations. Thank you, Professor Suresh. You can continue further. Yeah.
Now, just open the floor to question any of the speakers.